This video is the first in a series on number theory. For this video I'm just going to present some introductory information about the series of videos I intend to make, and what the plan will be, what sources we'll be using, etc. So I'll be using Hardy and Wright, the well-known elementary number theory textbook. I'm using the 6th edition, and one of the reasons that I've chosen to do this series on number theory is that, especially with elementary number theory, and if you've read Hardy Wright, or if you've had a look at it, you'll see that one of the things that book achieves is it gets quite a lot done using a minimal amount of notation and prerequisites. Number theory is one of the areas of maths that doesn't require a great deal of prior knowledge to get started. The barrier for entry is quite low. Doesn't mean it's an easy subject, but you don't need to know a whole lot to get started. So with that in mind, I've chosen to make a series on number theory. You don't need to use the 6th edition or any edition. I think there are some older versions available for free online. These videos should be self-contained, so let's read it. So the plan is to cover prime numbers, some basic, well, the very first order of business is setting up some simple set notation and logic notation. So I can probably do that right now in this video. So this is just the notation that Hardy and Wright set up on the first page before the text even begins. So we're going to borrow 4 symbols from formal logic. They are the implication arrow, the equivalence symbol, the there exists symbol or there is an symbol, and the as a member of symbol. Or, well, those are the 4 symbols we'll be using. As I said, this is the implication arrow. This is commonly seen in formal logic settings where you have some statement P, some proposition that can be either true or false, and if the proposition P logically implies the proposition Q, then we would write P implies Q in this way. And you'll also see it in proofs where once a certain result is arrived at, we can immediately conclude other results that logically must follow from the initial result. So that's the implication arrow. This symbol, it's hard to draw the lines very close together, or I find it is at least, without being a bit messy with the symbol. This just means that something is equivalent to something else. So it's like the equality sign or the equal symbol that you're more familiar with, perhaps. But it may apply in more general situations, such as modular arithmetic and so on. But we'll see more as we go on what this can do. So that's equivalence. So this backwards E symbol means exists and or there exists. So you could say there exists something X such that X or proposition P holds for this object X. We would use that symbol. And lastly, this symbol here if I say that X is a member of A, that means that this thing X is an element of a set A, or it could be a class of elements. Or if you've seen the video I made on De Morgan's laws, this notation is also defined there. But that's just the inclusion symbol, or as a member of